Yeah, let's start. So uh, we discussed about the stack, and I told you that whatever tool we are learning in this subject, we will try to use these tools to solve any kind of real life problem, right? So before that, we have to learn this data structure first. What we started with the stack, yesterday we discussed. Today we will discuss about the queue, its algorithm, the principle followed by queue. Then we will implement this algorithm in coding. Simply we will write code, right? Again, I repeat that writing codes or this practical is not in your exam, but always my intention is just to get through in your exam must not be your purpose. Your purpose is to learn something so that you will be able to prepare yourself industry ready, at least at the beginning level. Because if you are supposed to join in IT industry, your post will be junior software developer, right? And you are from the mother stream, electrical. So many scopes are there for the electrical guys, okay, where there are so many softwares are being developed which will work in the electrical field, electrical domain. Okay, for that, you people must have the priority to get into that domain where you have a prerequisite knowledge about the electrical technology, and having that knowledge, utilizing that, you will be utilizing that knowledge, you will develop your software, right, on that particular domain. It is valid for every domain. Okay, so we will be implementing these tools, we will write codes, we will show you how to write codes and how it is executing. Okay, using C, we will be developing the codes. And after that, we will try to use these tools to solve some real life problem. So where we uh, must use these tools, right? Stack, queue, means using this stack and queue, we will try to solve other problems. Okay, that is definitely in your syllabus also. So let us start today's discussion regarding stack. So let me start presenting. Okay, all of you be attentive.
Yes, sir.
The screen is visible.
Yes, sir.
Yeah. See, this queue topic is data structure and algorithm queue. Just like stack, you know that stack maintains last in, first out principle. The elements which will be inserted at last will be removed first. Here, the queue maintains FIFO, first in, first out, in this way. There is so many curves standing in a queue, and it will be processed or it will be removed from the queue according to the FIFO principle. Okay? Queue represents. So this is all data, the real life scenario, and the data. So data will be processed. The data which has been inserted in the queue first will be processed first. Got it? Okay. So first in, first out. Last in, last out. Basic operation like stack, there were two operations. One is push and pop. Here, Q and DQ. NQ means to insert an element into the queue is NQ. DQ is functional when to remove an element from the queue maintaining FIFO principle. Peek, this function, what it does, it just picks up the element which is standing in front, right? First element. It will just pick the first element. Likewise, stack, here also we have to check whether the queue is full or not. If the queue is full, then there is no scope, to insert any more element in the queue. If the queue is empty, then we will not do anything. We will not try to remove any element from the queue because the queue is empty, right? And again, I told you this is full and is empty. These checking or these constraints are valid generally for the in case of static memory allocation. It is not valid in that way in case of dynamic memory allocation, because in dynamic memory allocation in general we have no restriction to allocate or to create memory at runtime. Which restriction is there in case of array, that is static memory allocation? Because I repeat, in array you cannot modify the size of the array at the time of the program. Oh, Akash Gayan. Akash Gayan, try to join the class in time. Okay. So this is only valid for the case in the case of static memory allocation and simply the array. It is not valid in case of dynamic memory allocation, which you will be studying later while you will study linked list. Okay, it's very important, but because in real life we generally don't prefer this array, we always prefer the dynamic memory allocation, that is linked list. You always opt to implement linked list. Got it?
Yes, sir.
Okay. So in stack we have two important parameters to consider. One is the size of the stack. Here also it is valid, size of the queue, and there was a single parameter which was very important, that is knowledge about top, the element which is placed in the top position, right? Because every time we have to manipulate top, that parameter. But here, generally, like top, here we will be dealing with two important parameters, front and rear, not on a single parameter, front and rear. Always we will be changing the front and rear as and when required. Got it?
Yes, sir.
Simple algorithm, return this peak in peak, here return q front. Q front means this element, if the array is q, then we are just picking up the element which is there placed in the front position. So we pick, this pick function is just picking the element which is at the first which is placed in the first position in the queue, right? Is full. Similarly, we are checking when we can consider that will judge that whether the queue is full or not when the array size will be full, right? When the array size will be full, because you know that if in this case, if say this many number of elements can be stored in a queue, then it's, let's say 1 2 3 4. If the size of the array is 4, then rear, if the queue is full, then rear will hold which position? Fourth position. Front will hold which position? First position, this one. So 1 2 3 4. In case of array, 0 1 2 3. So we will be checking whether the maximum size of the array has reached to the value of the q or not. If it is empty, then q will point here, and there is another one room left for the element to be inserted in the queue. So here up to this position, q, here up to this position q is not full. When we will be inserting another element, that q is full, means q will reach to the value of the array size. Got it? Okay, queue always hold the position of the last element in the queue. If the last element, the position of the last element reaches to the maximum size of the array, we can say that the queue is full, right? Got it?
Yes, sir.
Yes, sir.
All of you, yeah. So here that is we're checking if the rear value of the rear equals to max size, then return true, means queue is full. If not, return false, queue is not full yet. Got it? Here in C, it is in general language we have written, it is called algorithm, or it is coding. Try to get the difference. Here it is a general language we are writing, maintaining a particular format, simply English language we are writing, maintaining a particular format. It's called algorithm. But here, when we are implementing this algorithm using any language, we have to go by the convention of that language. See, here it is C. So you know,
Yes.
rear means if there are 4 elements, the map rear will hold the last position, means 3, not 4, because this array index starts from 0. First position is indicated by 0, second position is indicated by 2. Similarly, the fourth position means max size is 4, it will be indicated by 3. So when the rear is equal becomes 3, for example, then you can say it's full. So it has maintained the convention of C, right? Got it? In the last class,
Yes,
I
sir.
about this. An algorithm is empty. Similarly, if front is less than minimum or front is greater than period, then it is true. Okay. Is empty, so means uh, is empty. Is empty. See, when the queue is empty, means there at no element is there in the queue. That's why it's empty. When we can say that if there is a single element in the queue at least, we can then what will be the value of front? If only a single element is there, value of the front will be what? By the C, which will be the value if there is a single element in the queue, which will be the value of front.
One, sir.
Tell me. Who will answer? If there is only single element left, single element present in the queue, which will be the value of the front?
Zero, sir.
0, exactly 0. And what will be the value of rear?
Sir.
Only a single element is there. You said
One, sir.
correct. 1. Somarendru,
Yes, sir.
think properly. I said a single element is there. What Meganko has said is absolutely right, that value of the front will be 0 because the array index starts from 0. Right. And what will be the value of rear? What will be the value of rear?
0.
Exactly. Array, you are the only person standing in the queue. So you are the front and you are also the rear, na? Huh?
Yes, sir.
Not applying. You are only person in the queue. So you are the first and you are the last, right? Okay. In an athlete, any kind of athlete competition, well, so you are only person, so you are the first person, right? No competitive, no competitors are there. So you are the first and you are the last. So you will get the prize, right? So in this way. So in front and rear value will be same. And when there are 2 elements, then what will be the value of rear? Value
So
of
1.
1, right? In the second position, means there are 2 elements. The first position is indicated by 0, means the value of the front will be 0. The value of front will not be changed, right? But value of the rear will be changed because the person will come, will stand after you, right? The value of the rear will be changed. Now that person will point to the rear position, right? The value of the rear will be 1. In this way, always, while inserting the elements in the queue, always value of rear will keep on changing, isn't it?
Yes,
Right?
sir.
And while removing the elements from the queue, value of rear will not be changed. Value of the front will be changed. Got it? You just see the picture here. Here it is front and it is rear. See, if this way in the rear has been changed, and when it will start removing the elements, the front was there, now front will be here, now front will be here, now front will be here. One by one element will be left from the queue. So eventually, if only one element is there to leave, so value of the front and rear will be same. Then also, right? Only one element is left to remove. Then, so how will you check that queue is empty? If that the front comes here and rear comes here, front will be changed. Front will be changed every time now when we are removing the elements, right? So in there may be two cases when we can say that the queue is empty. These two cases here. Front less than 0, right? Front less than 0 means front minus 1. So there are no elements in the queue, because if any at least one element is there, then front value of the front would have been 0. Taito, what
Yes,
Mriganka?
sir.
Yes, sir. Yes,
And
sir.
after removing all the elements from the queue, we are changing the value of front always to front, the value of the, when there's only single element to remove from the element from the queue, and front will be equal to the rear, what I said just now. Okay. And after that, if we want to, after that element is also removed, the value of the front will be changed, and front value of the front will be greater than rear, right? So in these two cases, we can say that queue is empty. So we have to put these two conditions in this function. We can judge whether the queue is empty or not. Okay. Okay. Now that MQ operation we have written step by step. Check if the queue is full. If the queue is full, produce overflow error. Overflow means it has gone beyond of the array boundary, so overflow occurs and exit. Step 3, if the queue is not full, what we are doing, we are incrementing the rear pointer to point the next empty space. Got it? What I said, when the second people joins, so that the rear position will be, now the second one means from 0 it will be changed to 1, right? Step 4, add data element to that queue location. First, we are changing the location, and then in that location, we are storing the data. We are adding the data where the rear is pointing, right? Where the rear is located. Return success this way. We are inserting the elements always here at present in this here in this case, at presently rear is pointing here. When we intend to add, here we will not say push or pop. Okay, typically we say add and remove. Okay, so when we intend to add the next element, what we have to do, we have to change the position of the rear, the next location. First rear will come here, then in that location that element will be inserted. Got it? Okay. Who is saying, sir, what about data structure? Let me see. Who is it? What about data structure? Sir, what happened? Means, who is this? Shayan Vadai. Sharon, did you message just now? Did you send a message right now? Sir, what happened? Is your phone number is 90389911171? Sharon? Sharon, respond.
Yes, sir.
Did you send the message just now
Yes,
to the group?
yes, sir.
So why? You didn't notice that class has already started? Huh? So before
Yes, sir.
joining, why are you asking this silly question? First you try whether you are able to join or not. Then you send the message, na? Okay.
Yes, sir.
Okay. So let us go back to the discussion. So this way, first we will be changing the position of the rear, then in that position we will insert the element. And Sayon, try to join in the class, don't be late. Okay, Q and Q. So this NQ algorithm we have written here to insert an element. We are calling this NQ operation. This NQ operation. So to insert an element first, we have to check whether Q is full or not. If full, then return overflow. And if not, then what we are doing, we are changing the value of the rear class to 1 Q rear, and in that position, we are inserting the element data return true. Got it? Okay. Now, in the using the convention of C, we are checking this full function first. If it is full, when it is true, then return 0, right? If not, then rear, you are incrementing the value of the rear, and in that position rear is here we have taken Q as array, and in that position rear we are inserting the element. Okay. In the next class, we will be writing the entire program. Okay, I'm showing part by part, piece of code, so that you can concentrate on that particular operation. Okay, specifically. That's why explaining this piece of code. Okay, so here is return one, if it's true, return two is fine. Return 1 and 0 means it's been done successfully. NQ operation has been done successfully. Return 0 means we are not able to insert the element, that's why return 0. Okay. Now DQ operation. Just opposite of this in DQ operation, what we are doing, we are changing the value of rear always, right? A value of front always, not rear. In NQ operation, we change the value of rear always here. After removing each and every element, we will be changing the value of front every time, right? Step one first, but before we go on removing or before we go on deleting the elements, we have to check always whether the queue is empty or not, right? To check if the queue is empty or not. First step. Second step, if the queue is empty, then produce underflow error and exit. Okay. In that case, that message we produce, that is overflow, means the boundary has been exceeded. Here, underflow means no element is there in the queue. Step 3, if the queue is not empty, then we will proceed to access the data where front is pointing, right? We have to remove the first element always from the queue. When we will be removing the element from the queue, or when we processing the elements in the queue, always we will process the first one. So it will be processed first one. So we have to check which element is there in the front position. So if the queue is not empty, access the data. We have to access the data to delete where front is pointing. Then we will change the value of front. Front will come here. Front now will point to the next location, that is B in this case. So increment front pointer to point the next available data element here. Return success. Very easy. Right, in this way, here after the A is removed, the value of the front will be changed. The value of the front will point to the next element B, right? In this way, again these at times front will have the value of rear, right? When only one element is left in the stack in the queue. That we will try to, if we try to, after that also, if we try to remove the element from the queue, we will check that front value of the front will come here. Then we are checking that constraint whether the value of the front is greater than or rear. If it is greater than or rear, then we can consider that queue is empty. No element is left in the queue to be removed. So in simple language, we have written this algorithm for DQ operation. We have to check whether queue is empty, it can underflow if it's true. If not, then we have to access the data. We are accessing the data first. We are storing the data in some variable, right? Is this here in this case A, we are storing the data in some another variable store, okay? Where the front is pointing, and after that we are incrementing the value of front. We are incrementing the value of front, right? We can do. So DQ operation is done. Now we have to check in A. This is just what we say is empty. We have to check is empty. Is empty. This one. Okay. This is in algorithmic language. This is in C. We have to call this operation function is empty, right? That we have already defined what happened in case of is empty, right? Is empty. What this function? This function is empty here. Just wait. Is empty. Is empty. Boolean is empty. Two conditions just I discussed. When we can consider that Q is empty, if the value of the front less than 0 means front is -1, then no element is there to be. And here in case of when the front reaches the value which is greater than rear, then I can say that all the elements are deleted, so it is empty. So these two cases may occur in case of Q is empty, right? So that is that function we are calling here. This function we are calling is empty. If it is true, then return 0. If not, then we will store the front element in some another variable data, right? Here the how we will access just the index number. The index number of the front and the array name is Q. Okay. So we are storing the data, storing that element in another variable, and after that we are changing the value of the front. Now value of the front will point to the next location. That's why you are incrementing the value by 1. Front is front plus 1. Return data. Clear? Finished. Okay. Any question from you? Any question?
Understood, sir.
All of you understood, or any portion you are yet to understand? Any one of you? Any one of you? See, in this virtual classroom, what happened that I can't see your expression. Otherwise, in physically, I just get to know seeing your expression, who understood or not. Okay, so it's been very difficult for me. If you don't cooperate, I will not understand who understood or who didn't understand. Okay, so please cooperate. I will not mind to reiterate to
Understood.
understood. Now all of you, Bhagbosri, understood?
Yes, sir. Understood, sir.
Saurabh Nyogi, understood?
Understood, sir.
Shiranjit, Pritam.
Yes, sir.
Pritam is very punctual. Always.
Yes, sir. Understood.
Pritam, Bhagbosri, Somarandu, people are very punctual. I noticed this one. And this one, who is this? This means after I am not getting actually. Sovon, Sovon Mondol.
Yes, sir.
Sovon tried to join 30 minutes before, right, Sovon?
Yes, sir. Mistakenly.
No, actually, I always try to maintain the schedule, okay, because there are so many other activities we involve with, okay. So always try to time, and maybe some technical reasons. If I fail to join, I myself fail to join due to some system error, or I will inform you, right?
Okay.
And any other, it's not possible for me to ask everyone our names, okay. And see your system, my system is taking the attendance. You can see I have activated this one. I have Google Meet attendance. Okay. So already the timestamp is being recorded. So your attendance is already been recorded. Okay.
Okay.
Anyways, today your attendance has been increased a bit. It's 35. Okay, still 60% I can say. Still 40% is left to join. Okay. Anyways, so no question. Should I proceed to the next topic or should I stop it here? What do you say?
Sir,
Free. Feel
C
free.
program. Sir,
Should I
C program.
proceed to the next topic?
Sir, stack বা queue যে কোনো একটা C program.
Pritam, speak loudly.
Sir, stack বা queue যে কোনো একটা C programming স্যার করে দেখান না এক্সাম্পল।
Definitely I will show you everything stack and queue because stack programming writing program on C is still left, right? And definitely I will finish the stack, then I will go to this queue. But today I thought that theoretical part I'll be completing today. If I start writing the code, it will take 1 hour more, right? To explain the code. It's not that I am copying and I just or writing the code and I am executing the code, you will be satisfied. All of you have to understand each and every statement, right? So what I plan in the next day, I will show you. Okay, it's ready for me. Okay, and what I planned that I will be discussing a bit of its implementation, right? A bit of its implementation means where we can implement this stack tool. Okay, that brief discussion I will start. I planned today. Okay, so let us do that one. In the next class, I will show you how to write code, and I will show you writing and executing the code. Okay, Pritam.
Okay, sir.
Okay, sir.
Thank you, sir.
So today, no, not thank you. Don't leave the class. Okay. Okay. So what I planned that I will be showing, I'm discussing what is the implementation of stack. Okay. So let us give a brief idea about that. See, have you ever thought of that how that mathematical expression are being processed by the computer or the processor? See, when you are adding simple addition, 2 plus 4, place the calculator. Okay, for example, and that actually what it does in case of computer also, right? What is the difference between the calculator and computer? Could anyone answer? Okay, don't waste my time. So I will discuss next time. What is your idea? What is the difference between the calculator and this computer? Anyways, I think you know all this. It's very basic question of kids, right? So anyways, so how it process? Let's say 2 plus 4. We know 2 plus 4 is 6, right? So in general, if I write a single expression, summation S is equal to A plus B. How the processor processes it? It's called infix expression. The expression we generally use in using the mathematical notation is called infix expression. That is A plus B. But our processor doesn't process this expression in that way. It converts its expression into some another form. Then it processes. Probably I think you people didn't have any idea about this, right? There are 2 forms available which the processor converts into from infix expression, then it performs the operation on that expression. 2 forms. One is prefix form, another is postfix form. It is also in your syllabus. It is called infix expression, notation of expression. So let me present that one in a brief way. Okay. Okay. Don't do. Are you feeling?
Okay, sir.
Are you feeling exhausted? I will not take that much time, only 5 minutes time. Okay. So please be attentive. Fine. Okay.
Yes, sir.
Okay, sir.
Okay, sir.
Okay, let's start on this stuff. Is expression parsing. Okay, it is in Word. Let me. I think I have saved it in. I've saved it in this PDF format also. Or let us. Let us. No, it's not that. Okay, in this folder, I think I've kept this one on expression, data structure, algorithm, expression, stack queue, expression. This one, no, it is the people. Just a minute. Expression. Okay. Now let me convert in PDF. It will be. It will look good for you. So as PDF. Video. Okay. Now let me save it. Desktop temporarily. I'll. Most of all this is already exist. Yes. Anyways. Okay. Fine. Yeah, I prepared it before and that's why it's going. Anyways, so this is visible now for you, the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
See, that's not what I said, that's notation. Okay, data structure, expression parsing. This is another topic in your, as per your syllabus, and very important in data structure. Here we will use the stack as a tool to implement this one. Just conversion of infix expression to prefix or postfix. Prefix we call polish notation, postfix we call reverse polish, right? Infix notation and postfix and prefix and postfix. I'm not reading out all this. You can read this one, you will be getting this one. I'm just going straight directly to the example. Okay, this is just now what I said. Just we are adding up two elements A and B. In general, the variable A and variable B. This is called what? This is called operand, and this is called operator. Okay, operator, plus, minus, star, division. These are called operator, mathematical operator. There are so many operators available in C also, logical and mathematical. And the operators which are associated by the variables called operands. Okay, so computer first converts these infix notation either in the form of prefix or postfix. In prefix, we generate this plus AB, means operator always comes first, then two variables AB, two operands. In postfix, operator followed by the operands. In prefix, operator followed by the operands. Here, operands followed by the operator, right? So here also, according to the priority of the operators, the expression will be processed. Here you know it is in bracket, so this operation will be done first, but by default, had it not been any bracket there, then this multiplication would have been processed first according to the priority. But since it is within a bracket, the operation of this sub expression will be processed first. So A plus B, first this will be processed according to the prefix. What will happen? Plus AB, right? Plus AB, isn't it?
Yes, sir.
Then star, then C. Now plus AB will be treated as a single element. Plus AB will be processed as a single element. Then plus AB, you can put an underline plus AB, then star and C. Then ultimately what will happen? Star plus AB, C. This we got it. Okay. In case of postfix, what will happen? It will come as AB plus as a single element, then AB plus star C, means eventually we'll get AB plus C star in postfix. Okay, another example of this. So how to convert it, this entire algorithm we will be discussing. That is conversion of infix notation from prefix or conversion of infix notation into postfix. Using stack tool, we will be doing this one. These are different example. You will just read out and you have to, I will be giving you some assignment. Okay, it's very easy. Okay, you can score very easily from this topic. You will be getting 8 to 10 marks on this every year. Every year, some questions you'll be getting from this topic. Just convert the infinite expression. An example will be given for to convert the infinite expression, and you will be asked to convert this infinite expression to prefix or postfix. And you may also be asked to write its algorithm that we will discuss later. Okay. So this is called parsing. This is called parsing. Okay.
Okay, sir.
Highest priority precedence. Precedence and associativity we always keep in mind while converting this one. I will give you the notes. Postfix evaluation. There is another algorithm when after converting this into expression to postfix or prefix, if we are supposed to evaluate that one, how computer process evaluate this one is the algorithm for this. So in the next class I will be discussing, but as Pritam told, in the next class we will show how to run the program, how to write a program, and how to execute the program in stack and queue. Then we will discuss all this. Okay.
Sir,
So
Okay, sir.
today, let's stop our discussion. Let's call it an end. Okay, this class.
Okay,
Okay.
sir. Okay, sir.
Okay, fine. Thank you. Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Oh, fine.
Thank you, sir.
Oh.
Thank you, sir.
Hmm.